Hi everyone, this is J. Hariharan from PCA section, UVT University. It is 24 PQ 180449. And today I am giving segment about this subject PTSP and the topic is autocorrelation, cross correlation functions. And before going into the topic, let us know what is the random process. Random process is nothing but a stochastic process. It is a mathematical model that describes a collection of random variables indexed by parameters, typically time. Each random variable is a process representing the outcome or output of a random experiment at a specific position in time. And this random, there are different types of random processes, mainly continuous random process, discrete random process, continuous random sequence, discrete random sequence. And in continuous random process, this time and random variable both are continuous in nature. And continuous means it can have values to up minus infinity to plus infinity. Even integer fraction part values are also included. And discrete random process is nothing but this time is discrete but amplitude is continuous. And continuous random sequence. Continuous random sequence is nothing but the time is continuous, but this amplitude is discrete. And a discrete random sequence means both amplitude, I mean random variable and time both are in discrete nature. And let us know about what is autocorrelation function. Autocorrelation function is nothing but the similarities between these values of a same function at a different time instance, like t1 and t2, and it is represented by rxx of t1 comma t2, and here e is nothing but the expectation. And capital the autocorrelation means the relation between same functions, no? Hence we take x, and this is also x of t1 and x of t2. And as we said earlier, x1 is equal to x of t1 and x2 is equal to x of t2, and we substitute the here, and we get e of x1 comma e of x1 into x2. And this autocorrelation function formula for integration is this one: rxx of t1 comma t2 is equal to minus infinity to infinity x1 and x2 into function of x1 comma x2 t1 comma t2 dx dy. And this is about the autocorrelation function. And now we will discuss about the cross correlation function. It is nothing but the relation between two different random processes. In autocorrelation function, we took the same random process but at different time instance. But here in cross correlation function, we take two different random processes like x of t and y of t. And x and y are random variables, and it is represented as r of xy. And in autocorrelation, we will represent as r of xx or r of yy. In autocorrelation, both are same, but in cross correlation, r, x, and y, two different values we will take. And t1 comma t2 are in time domain. And here e is nothing but the expectation. And cross correlation of x of t1 and y of t2. X is one different random process, and y is a different random process. And this and this is the function joint density function, joint probability density function equation. It is nothing minus infinity to infinity xy fxy of x comma y t1 comma t2 of dx dy. And let us discuss about the properties of autocorrelation function and cross correlation function. Properties of autocorrelation function. The mean square value of x of t means e of x square of t is equal to rxx of 0. Means it is the maximum value that can be obtained in an autocorrelation function. And let us discuss how we derived this function. E of x square of t is equal to rxx of 0. This is the autocorrelation function equation. Rxx of tau is equal to E of x of t into E of x of t plus tau. And this is the shifting in tau. And if we keep tau is equal to 0, Rxx of 0 is equal to E of x of t into x of t. X of t into x of t is nothing but x of t square. And this is E of x of t square. It is nothing but the mean square value. It is equal to the Rxx of 0. And this is the property 1 in this autocorrelation function. Now, autocorrelation process and property 2. The autocorrelation property 2 is nothing but it has a maximum value at the origin. Autocorrelation function has maximum value at the origin, and it is also called as mean square value. And let us derive how we got that. Here x1 or x of t1 and x of t2 are two random variables. Both are positive quantities. And x of t1 plus or minus x of t2 whole square greater than or equal to 0. And we apply expectation to this equation. Expectation of x of t1 plus or minus x of t2 whole square. And we derive this e of squaring, we get x square of t1 plus x square of t2 plus or minus 2 x of t1 x of t2 greater than or equal to 0. And expectation of x square of t1 plus expectation of x square of t2 plus expectation of 2 into e of x of t1 into x of t2 is greater than or equal to 0. And from the earlier result, in property 1, e of x square of t is equal to rxx of 0. It is nothing but mean square mean square value. And rxx of 0 plus rxx of 0, we substitute e of x square is equal to rxx of 0. Rxx of 0 plus rxx of 0 plus 2 rxx of t1 comma t2 is greater than 0. And 2 rxx of 0, we add this both 2 rxx of 0 plus 2 rxx of tau is greater than or equal to 0. And this rxx of tau is go into this side. And rxx of 0 is greater than or equal to rxx of minus tau. And hence proved. It has maximum value at the origin. And let us discuss the property 3. Rxx of tau is an even function. Rxx of tau is nothing but the autocorrelation, and it is an even function. Means Rxx of minus tau is equal to Rxx of tau. It is like in signal systems also. Rxx of tau is equal to E of x of t into E of x of t plus tau. And let us substitute u is equal to t minus tau. And let us put t is equal to minus tau. And if we kept t is equal to minus tau, Rxx of minus tau is equal to E of here t minus tau will become, and we substitute u is equal to t minus tau, hence we will keep u plus tau to x of u, and this is the equation of rxx of minus tau is equal to u of x of u into x of u plus tau, and this is nothing but rxx of tau, and hence proved rxx of minus tau is equal to rxx of tau. And let us discuss about the properties of the cross correlation functions also. Properties of the cross correlation function. Rxy of tau is nothing but the cross correlation function, and Ryx of tau minus tau is also a cross correlation function. These both are symmetrical in property. Proof: the cross correlation function of x1 of t and x2 of t is nothing but Rxy of tau is equal to expectation of x of t into y of t plus tau. In autocorrelation, we will take in the x plus, we will y plus, we will take x here. But this is cross correlation, hence we take two different random processes like x and y. Hence we took this equation. And ryx of tau means this y will come here and this x will replace it. Ry of tau, ry of t into x of t plus tau. And if we keep tau is equal to minus t, and this ryx of minus t, ryx of minus tau, then we will get e of y tau into x of t minus tau, and substitute t minus tau is equal to u, and ryx of minus tau is equal to e of in t means u plus tau, and we put t is equal to u plus tau, and t minus tau is equal to u here, and the value is equal to e of x of u into y of u plus tau, and it is nothing but rxy of tau. Hence we proved ryx of minus tau is equal to rxy of tau. This is one property of the cross correlation function, cross correlation process. And property 2, Rxy of tau and Ryy of tau are the cross autocorrelation functions of x of t and y of t1 respectively, then cross correlation function is satisfied this equation. E of x of t by root of Rx of 0 plus or minus y of t plus tau by Ryy of 0 whole square. And squaring inside we will get x square of t and square root cancel and we will get Rx of 0 plus or minus y square of t plus tau by square root cancel Ryy of 0 plus 2ab not 2 into x of t into y of t plus tau by root of Rx of 0 into Ryy of 0. And if we apply this expectation on the inside, we will get expectation of, and we will get expectation of E of x square is equal to Rx of 0. Hence we proved in the autocorrelation function property 1. We substitute that and Ryy of t plus tau is equal to Ryy of 0. And expectation of x of t into y of t plus tau is nothing but Rxy of tau, which is autocorrelation function. And if we substitute that E of x square means Rxx of 0, we will get Rxx of 0 by Rxx of 0 plus or minus Ryy of 0 by Ryy of 0 plus or minus 2 into Rxy of tau by root of 2xx into 0 into Ryy of 0 greater than or equal to 0. This value will become 1, this value will become 1, and 1 plus 1 is equal to 2. 2 plus 2 into Rxy of tau by root of Rxx of 0 into Ryy of 0 is greater than or equal to 0. And if you send this 2 to this side, you will get plus or minus Rxy of tau, which is by root of Rxx of 0 and Ryy of 0 is less than 1. And if we send this root of Rxx of 0 into Ry of 0 this side, we will get Rxy of tau is equal to is less than or equal to root of Rxx of 0 into Ry of 0. And this is the property, second property. And this is the last property. And if two random processes x and y are said to be independent, independent means R of E, R of E of xy can be written as E of x into E of y. Both are independent in nature, and one thing does not depend on the another thing. And we will get Rxy of tau is equal to x bar into y bar. This Rxy of tau is nothing but the cross correlation function. And let us take two random processes x of t1 and y of t2. Both are WSS. We know that this is the equation Rxy of tau is equal to E of x of tau into y of t plus tau. And hence this is the independent in nature. We can write this as expectation of x of t into expectation of y of t, and this is written here. Rxy of tau is equal to expectation of x of t into expectation of y of t plus tau, and expectation of x of t is nothing but x bar, and expectation of y of t plus tau is nothing but y bar, and hence proved. This is the property 3, and this is the sender. Thank you.